Hello and welcome to this Edexcel Further Maths Statistics 1 video looking at using the mean and variance for the geometric distribution. This slide just reminds you of the definition of the geometric distribution and gives the probability function. And this slide just reminds you of the definition of the random variable x, where x is distributed geometrically. And a quick reminder that both the probability distribution, the mean and the variance are given to you in the formula book. So I've included at the top of this slide the essential information that you're going to need in order to solve the examples we're going to be looking at. And it may be worthwhile just pausing the video for a short while and just reading through this example before I start to put the solution on the screen for you. So if we identify the model we have in this case, the parameter involved P is 0.4, where P represents the probability that a pool player pots a ball on the initial break of a game. I'm not going to write that all out because I think I'd run out of space, but it's good practice to write that out in an exam when you're doing your solution. And the random variable x involved in this distribution would represent the number of games before a player pots the first ball on the initial break. And again, I haven't written that all out, but it's good practice to do that when you're writing a solution yourself. And we know that x follows a geometric distribution with parameter 0.4, and we've been asked to find the expected number of games, ex or mu, which is 1 divided by p. We've been asked to find the variance for x, sigma squared, which is 1 minus p divided by p squared, and also the standard deviation for x. So this is a fairly simple example. The expected number of games before the player first pots a ball on the initial break, 1 divided by p, 1 divided by 0.4, which is 2.5. So we would expect to wait 2.5 games on average before the player first pots a ball on the initial break. And then to find the variance is 1 minus p, so that's 0.6, divided by p squared, 0.4 squared, which gives 3.75, and that implies that the standard deviation of x, or sigma, will be the square root of 3.75, which is 1.94. So again, with this second example, you may like to just pause a moment and read through the example yourself before I start to do the solution for you. So if we identify the model here, P, our parameter, is 0.2, and P represents the probability of a defective product, and x, the random variable involved, is the number of inspections necessary to find the first defective product. And we have simply been asked to find the average number of inspections to find the first defective product. So we simply want the mean for x, or the expected value for x, which is 1 divided by P, 1 divided by 0.2, or 5. And that means that we would expect on average to find one defective product every 5 inspections. And that concludes the end of this series of videos on the geometric distribution.